Hello and welcome to our video on finding the area of common 2D shapes. Just a reminder that area is the number of square units inside a shape. So if we drew lots of little squares and counted them all up on the inside, that would be the area. So it's the inside part of the shape. For the common shapes that I've got drawn here, there are some formulas that can help us find the area rather than trying to count lots of little squares. We can just use our formulas. So we're going to start with the easier ones, which you should remember from earlier years, and then we'll get into adding some extra ones. You'll want to make sure that you have a copy of all of these formulas somewhere in your summary book. Would be an excellent place to put them. And you also, I've put the diagrams in because you need to know what the different letters in the formulas mean. So that's what we're going to practice doing in this unit, using the different letters and working out how we can put them into the formula. Because there's no point knowing a formula if you don't know how to use it. So the first one, for a square, relatively easy. We've got the length and the width is the same as the length, so it's just L times L, which is L squared. That's an L there. Rectangle, length times width. I think everyone's confident with that one. Triangle, half base times height. You could also write it as base plus height divided by 2, gets you the same result. And you need to make sure you know the base is all the way going along the bottom and the height is going straight up at right angles. It's called the perpendicular height because it's at right angles. So we can't use one of these sides at an angle. You need to use the straight up and down perpendicular height. For a rhombus, and we're getting into the more complicated shapes now. A rhombus is a square pushed sideways. A parallelogram is a rectangle pushed sideways. So you need to know which one's which. For the rhombus, you need to get the long length all the way from the tip to the other tip, and that's known as Y. This width going from this tip to this tip, which is known as X. And we use the formula half of X times Y. For a parallelogram, it's a lot like a rectangle. Base, but instead of the slanted side, it's again the perpendicular height. So straight up and down at right angles. Base times height for parallelogram. For a trapezium, we need to have the shorter length, the longer length, and the perpendicular height again. So it's a half A plus B, the two lengths, times H, the perpendicular height. For a kite, you need to know this length and this length. And the formula is a half X times Y. So we're going to do some examples in a moment using some of these formulas. And you need to get lots of practice in making sure you know how to find all of those different letters. The rule for the area of a circle is pi r squared, where r is the radius. Just a reminder that the radius is halfway across. Diameter is all the way across. Radius is the halfway one. And we're also adding the rule for area of a sector. A sector is part of a circle, like a piece of pie. I've got a diagram here. And you need to use the rule theta, which is this angle on the inside. Theta over 360 times pi r squared. So r is all the way along there because this is part of a larger circle, if that was drawn to look a lot more like a circle than it does. But you get the idea. When we're solving measurement problems, you need to follow similar steps to following any problem. And you'll need to show all of these sections in order to get full marks for your working. Here's an example. Find the area of this shape. First step we need to do is decide which formula we're going to use, and to do that we need to decide what kind of shape it is. If you'd like to pause the video and have a go at doing this one first yourself, you're welcome to, or you can just keep watching to see the worked solution. Once we decide which shape it is, it's a triangle. So we will use area equals a half base times height. Step 2, make sure all the measurements are in the same units. We've got kilometres, all good. Step 3, substitute values into the formula. And we need to make sure that it is the base and it is the perpendicular height that we've got, and we do. 1/2 times the base, which is 2.8, times the height, which is 1.3. If it helps you to label these, you can do that as well. Put a B here for base and an H here for height. Step 4, calculate your solution. If we put all of that into the calculator, we end up with 1.82. And the final step, same as in all our measurement work, we need to add the correct units. Now this time they're both in kilometres, but area is in square units, so we need to put a little squared on there, kilometres squared, for it to be correct. If you just wrote kilometres, it wouldn't be correct. We need kilometres squared, 1.82 kilometres squared. Example 2, I'll give you a minute to have a look at that one and pause if you'd like to have a go yourself first, and then you can have a look at the worked solution that I go through. Okay, for the worked solution, the first thing we need to do is work out which formula we're going to use. So this shape here is a trapezium. So we will use area equals 1/2 A plus B times H. Next step, make sure they're all in the same units, and they are. Third step, substitute our values in, and remember you can label your sides first, if that helps you. 1/2 0.2, which is A, plus 0.3 times 0.1. We put all of this into the calculator and we end up with 0.025. Final step, add the correct units, millimetres, and its area, so it needs to be millimetres squared. Example 3, pause now if you'd like a minute to have a go yourself. Hopefully you've had a second to have a go at this one. This is a circle, so we will use area equals pi r squared. Second step, make sure the measurements are in the same units. There's only one here, so that's okay. We can label this. That's the radius there, halfway across. Substitute the values, pi times 7 squared. Calculate, put this in the calculator. And we get 43.98 meters squared. Now we can also use formulas to find a missing side length if you are given the area in the question. So these are slightly harder problems, but we should be able to do them as well. For example, we're trying to find L, the side length here, and when we know the area is 206. So we use the same method, work out which shape it is. Area equals L squared. And we know the area is 206. And when we're undoing, we want to get L by itself. The opposite of squared is square root. So we'll need to do square root of 206 will equal L. If you put that in your calculator, you get 14.35. Now, because our area was in meters squared and we're only trying to find one side length, we only need to put the units in meters for this one. We're only finding length, so it's just in meters, not squared units. So that's our final answer. Little reminder there. Okay, example 5. You may wish to pause to have a go yourself first. I'm going to move on. This is a rhombus. So we will use area equals a half x times y. Let's make sure our units are all the same. This is meters, this is meters, this is meters, so it's all good. 1/2 times, oh, forgot to label them. X is already labelled, this will be y, and this is your area. 1/2 times x times y, which is 18. Oh no, I forgot to put our area in. Area is 80. Just substitute straight in there. So we want to try and get our x by itself. First of all, I'm going to take this half and times it by the 18 because we're timesing all these together, so I can times those two together. A half times 18 is the same as saying a half of 18, or if you're not confident, you could throw that in your calculator, and we would end up with 9. We've still got an x to multiply, equals 80. Now, to get the x by itself, we need to do the opposite of 9 times x. Divide both sides by 9. And we're left with x equals 8.89. And again, this is a length, so it's just meters.